In section 9.4, we're actually not doing a whole lot that's new. We're just kind of using what we've known already and taking this one step further. So that extra step is going to be factoring to solve quadratic equations. We've already factored quadratic equations in the last chapter, and now we're just going to see how we can get solutions from that. So again, our objective is going to be to solve those quadratic equations by factoring. I'm skipping through the first part a bit, but we can solve some quadratic equations, including equations where b is not 0, by using what we call the zero product property. So the multiplication property of 0, that's our rule that says that any number times 0 is going to be 0. So it's also equivalent if I have more than one number. If I have a and b, for example, if a is 0 or b is 0, then a times b will still be 0, because anything times 0, remember, is 0. So zero product property reverses that statement. That's kind of what we're using to solve these equations. For any real numbers a and b, so again, if I have any two numbers and I multiply them together to get 0, that means that one of them had to be 0. So either a is 0 or b is 0. So the way that we're going to use this in practice, say for example I have a factored quadratic equation, x plus 3 times x plus 2 is our two factors, then that means that either x plus 3 is 0 or x plus 2 is 0. If the whole thing is equal to 0, remember that means that either the first part or the second part was 0. So let's try that in practice with a couple solutions here. Looks like 4 actually. So just like that example, if I have x plus 1 and x minus 5, if I multiplied that to get 0, that means either the first factor is 0, x plus 1, or the second factor is 0, x minus 5. And all I have to do to find solutions is to solve both of those possibilities. So subtract 1 on both sides in our first equation, add 5 on both sides in the second equation, we get the two solutions, x is negative 1 or x is positive 5. So those two solutions would both be solutions, not one or the other. We would have them both as answers. Same kind of thing on part B. If these are my two factors, 2x plus 3 and x minus 4, if I multiply those to get 0, again that means that either 2x plus 3 was 0 or 3x minus 4 is 0. So if I want to solve, again if I'm working through my algebra steps, I just got to subtract and then divide, or in this case add and then divide, and I get my two answers. X is negative 3 over 2 or it's positive 4 over 3. And you probably know how to do these next ones. It's the same work, but I'll just show my steps. Again, I can get two possible solutions, either 2y plus 1 is 0 or y plus 14 is 0. And if I solve either of those possibilities, I get my two answers. Y is negative 1/2 or negative 14. Same thing on part D. I could have two possible solutions. If I solve both, I get either 2 over 7 or 4 over 5. And that's depending on which factor we're solving from. So two possible solutions means I have two answers that could work for my variable. So you can also use that zero product property to solve equations of the form ax squared plus bx plus c equals 0, if I can factor that first. So in the last few examples, that was already factored for us, but since we should know how to factor those quadratic equations anyway, that could be our first step before we end up finding solutions. So if I'm given an equation like this, m squared minus 5m minus 14 equals 0, first thing I want to do is factor that. And remember, to factor, I'm looking for numbers that multiply to get negative 14 and add to get negative 5. And I have that work off to the side. Those numbers should end up being negative 7 and 2. Negative 7 times 2 is negative 14. Negative 7 plus 2 is negative 5. And remember, if there's no leading coefficient, if that's just an m squared, then my two factors are just my two numbers. So m minus 7 and m plus 2 are your factors. So we all did that last chapter, so this should be nothing new from chapter 8. The only new step here is that since it's equal to 0, I'm just solving both of those factors. So either m minus 7 is 0 or m plus 2 is 0. So if I solve both, I get the solution 7 and negative 2. Same thing on part B. First thing you want to do is factor it. If I'm looking for numbers that multiply to get negative 20 and add to get 1, those two numbers should be 5 and negative 4. And just like the last one, it's a little bit faster if there's no leading coefficient. If it's just p squared, that means my two factors are p plus 5 and p minus 4. And if those are equal to 0, remember I'm just looking for either the first or second part to be 0, and numbers that should end up solving for that are negative 5 and positive 4. So part C is where we have to do a little bit more work. 2a squared minus 15a plus 18 equals 0. And this time if we're factoring, we got to remember it's a little bit more involved if my first coefficient's not 1. So if I have a 2 in front, that means I'm doing 2 times 18 to get 36. That's what I want to multiply my two numbers to get. But I still want to add to get that middle term, which is negative 15. So two numbers that should work for this are negative 12 and negative 3. They multiply to give us 36 and add to give us negative 15. And this is where, again, rather than just having our answer, it's not just going to be a minus 12 and a minus 3. I have to use those two numbers to break apart my middle term. So still the same first term, 2a squared, but now I'm using that minus 12 and minus 3 to rewrite our a term. So minus 12a minus 3a, and last term is going to stay in 18. And this is where we're looking at both of these as pairs. So of my first two numbers, I can factor out 2a, and I'm left with a minus 6. From our second two numbers, I can factor out a 3, but since this a term is negative, I want to also factor out that negative 3. So if I factor out negative 3 from my last two terms, I'm also left with a minus 6. Remember, we've done that step correctly if your parentheses are the same. And now that we do have those parentheses, remember one factor is going to be whatever is outside of those parentheses. So 2a minus 3 is going to be one of your factors, and the parentheses is going to be your other part. So a minus 6 is your other factor. Since we're just solving these where they're equal to 0, our only new step is just setting either the first or second factor to equal to 0. And if we solve both, we should get 3 over 2 and positive 6 as our two possible solutions. So sometimes also before solving our quadratic equation, we may need to add or subtract terms from each side in order to write the equation in standard form. Remember, standard forms where I have a quadratic equation and then I have that equal to 0. So sometimes I'll have to do that add or subtract, and then we'll still be factoring that expression. So that's what we're doing in that first practice problem, part A. Since I have 4x squared minus 21x equals 18, I want to take one step first, which is to subtract 18, and that way we have a side that's equal to 0. And now that I have all this on the left, now it's just like what we did up above. I'm looking to factor it, and there's no GCF I can divide first, but if I multiply the first and the last terms, I'm looking for two numbers that will multiply to give us negative 72 and still add to get us the middle of negative 21. Two numbers that should work for that are negative 24 and positive 3. So if I use that to rewrite my quadratic expression, I can factor those first two. Again, I can factor 4x from my first pair, and from the second pair, I can factor a 3. And remember, again, we did that correct if we see that the parentheses are both the same. So now that I've factored that as 4x plus 3 and x minus 6, if I set that equal to 0, that means that either the first factor is 0 or the second factor is 0. So our only steps from here is just to solve our equation. If I subtract 3 and then divide by 4, I get negative 3 over 4. Or also if I just add 6 to this other factor, I get my second answer. So two possible solutions, negative 3/4 and positive 6. So part B starts off the same. I want to make one side equal to 0 first, so that's why I'm adding 49 to start. And if I've added 49 to both sides to get our 0, what we could recognize here is that I have what we call a perfect square trinomial. If I have a perfect square and there's a first term, perfect square is my last term, and if your middle term is the multiple of those first two terms put together, multiple times 2, then that's going to be factored as a perfect square trinomial. So I could take that down and factor that as x plus 7 quantity squared. I could also factor it by looking for numbers that multiply to get 49 and add to get 14, but that ends up being 7 and 7 anyway, so that would give us the same factor. If I'm trying to solve this, since there's only one possible factor, I only have to look for one possible solution. If I'm taking x plus 7 to be 0, if I just subtract 7, that just means I have one answer that's going to be negative 7. So negative 7 is the only solution to that quadratic equation. And this is also kind of answering our next question for us. Why do quadratic equations of the form x squared plus 2ax plus a squared equals 0, or x squared minus 2ax plus a squared equals 0 have only one real number solution? And that's just like what we saw up above on part B. If I have a perfect square, and again that middle term is both of them times 2, that means that if it's a perfect square trinomial, it's only going to have one possible factorization. I don't have x plus 7 times x minus 3 or something, for example. I just have a single factorization, so I'm just going to have a single solution. So make sure we have these notes complete and be ready for some practice in class.